So we're going to do sections 6.8 and 6.9 from the textbook, beginning on page 546, that we didn't have a chance to talk about in class. So in particular, we're going to talk about complex rational expressions. Those are rational expressions that have one or more rational expression in the numerator or in the denominator. So for example, 1 plus 2 over x is a rational expression in the numerator, and 3 is a rational expression in the denominator. So it's basically a fraction over a fraction. So another example, x plus y over 2 all over 2x over x plus 1. So they're looking kind of complicated, but basically it's a fraction over a fraction. So that makes it a complex rational expression. We're going to look at two ways of simplifying complex rational expressions. First method is to find the least common multiple of all of the denominators and multiply the result, the expression, by a fraction which is the least common multiple over the least common multiple. So let's start by looking at example 1 on page 546. So the example I've got is 1 over 2 plus 3 over 4 all over 5 over 6 minus 3 over 8. So in this method, we find the least common multiple of all of the denominators. Well, the denominators are 2, 4, 6, and 8. So if we find the least common multiple of those denominators, that is the smallest number that each of them divides into, that would have to be 24. 24 would be the smallest number that they all divide into. So now we're going to multiply this fraction by 1, but 1 is going to be represented as the least common multiple over the least common multiple. So 24 over 24. Now, when we multiply a fraction, we're going to multiply this numerator by this numerator and this denominator by this denominator. So that's going to be equal to 24 times 1 over 2 plus 3 over 4 all over 24 times 5 over 6 minus 3 over 8. Okay, so far? Now to do that, you multiply each term in the bracket. So we're going to get 24 times a half plus 24 times 3/4 all over 24 times 5/6 minus 24 times 3/8. Now that's going to simplify a little bit. 2 goes into 24 12 times. 4 goes into 24 6 times. So I end up with 12 plus 18. That's the 6 times the 3. In the bottom, 6 goes into 24 4 times. 8 goes into 24 3 times. So I end up with 4 times 5, which is 20, minus 3 times 3, which is 9. And that's going to be equal to a 30 on the top and an 11 on the bottom. So 30 over 11. Let's look at example 2 on page 547. So in this case, we have 3 over x plus 1 over 2x all over 1 over 3x minus 3 over 4x. So the same approach, we find the least common multiple of the denominators. Well, in this case, that's an x, a 2x, a 3x, and a 4x. So one of the items in there is going to be an x, but then we look at the coefficients, and the least common multiple of 2, 3, and 4 is going to be a 12. So it's going to be 12x. We're going to multiply the top and the bottom by 12x over 12x. So we can simplify that a little bit. Take the numerator, multiply it by this numerator. So that's going to be 12x times 3 over x plus 12x times 1 over 2x. Oh boy, running out of space here. All over 12x times 1 over 3x minus 12x times 3 over 4x. But that's going to simplify a bit as well. So the x will divide into the x 1 time. 2 will divide into the 12 6 times. X will divide into the x 1 time. 3x goes into 12x, that'll just be 4. 4x will go into 12x, that'll just be 3. So we'll end up with 12 times 3 over here, so that's 36, plus 6 times 1, just 6 there. And we get a 4 here, and we get a minus 9 here, so that's 42 over minus 5, which would be the same as minus 42 over 5, which is the same answer they got in the book, thank goodness. So there's another way we can approach it, and that's shown over the page, method 2 on page 548. And here, our approach is going to be to find individual common denominators for the numerator of the expression, and a different one for a different common denominator for the denominator of the expression, and then we simplify both the numerator and the denominator. So each of these approaches works, and it's up to you as to which one you think you might prefer. So example 1 on page 548. So it's 1 over 2 plus 3 over 4, all divided by 5 over 6 minus 3 over 8. Look familiar? I think that's the same one we had in the previous example. We're going to do it a different way this time. So this time we're again looking to find the least common multiple of the 2 and the 4 that we have here. Well, the least common multiple of 2 and 4 is in fact 4. So if we take that half and multiply it to get it to a common denominator of 4, we're going to have to multiply that 2 on the bottom by a 2 to get it to be a 4. So we'll multiply by 2 over 2. That's a 1, so it doesn't change anything. But now by multiplying by 2, the denominator is going to become a 4. This one's already got a denominator of 4, so we're not going to change it. Here for the denominator of our complex expression, we're looking for the common denominator of 6 and 8. So what is it that they will both divide into? Well, they will both divide into 24. 6 divides into 24, 8 divides into 24. What do we have to multiply 6 by in order to get 24? Well, it's 4. So we're going to take that 5/6, multiply it by 4 over 4, which is 1, but that's going to give us a denominator of 24. And over here, we got 3/8. 8 has to be multiplied by 3 to get 24, so we're going to multiply this part by 3 over 3. Again, it's a 1, but when we multiply, that'll become a 24. Okay, now we can do a little simplification. So in this case, we've got, when you multiply fractions, you multiply the numerators and denominators, so we'll have 2 over 4 plus 3 over 4, all over 20 over 24. Sorry, that's a minus. 9 over 24. And we can simplify the top piece to get it to be 5 over 4, all divided by, this is going to be 11 over 24. But when you divide fractions, you invert and multiply. So that'll be 5 over 4 times 24 over 11. Now that 4 will divide into 24 6 times. So we'll get 5 times 6 is 30, all over 11. So we end up with the same answer as we had before. Let's look now at number 5 on page 549. Okay, so this one is 3 over x plus 1 over 2x, all divided by 1 over 3x minus 3 over 4x. So again, with this second approach, we need to find the least common denominator for the numerator and for the denominator. So the least common denominator of x and 2x would be 2x. That is, both x and 2x divide into 2x. So I'm going to bring them to a common denominator in the top here of 2x. Well, to get x to be 2x, I'm going to have to multiply it by 2. So that's going to be 3 over x times 2 over 2. Again, that's a 1, so it's not changing anything, but when I multiply by this, I'll get 2x. And this one is already over 2x, so I'll just leave it the way it is. Now down in the bottom here, I need the least common denominator for 3x and 4x. Well, the x part is common, so the least common denominator for the 3 and the 4 would be 12, the smallest number that both divide into. So I want to bring this to be 12x on the bottom, on the denominator part. Well, in order to get the first fraction to be 12x, I got to multiply it by a 4, like this. For the second term, I want it to be 12x, so I got to multiply it by a 3. So it'll be 3 over 4x times 3 over 3. Now I'm going to have to simplify this a bit. So again, multiplying fractions, 2 times 3 is 6 over 2x plus 1 over 2x. Down in the bottom here, I'm going to have 4 over 12x minus 9 over 12x. But that's the same as 7 over 2x in the top and minus 5 over 12x in the bottom. Again, when you're dividing fractions, you invert and multiply, so that's 7 over 2x times minus 12x over 5. And that'll all simplify down to be, well, the x divides into the x once, the 2 goes into the 12 6 times, but I don't want to forget that minus sign I got here, so it's going to end up being a minus number. Minus 7 times 6 is 42, and on the bottom I've got just 1 times 5, so it's a 5, so I get a minus 42 over 5. Okay? Next we're going to move over